There are four states of matter. There are solids, which is like you and me. There's liquids, which is like our blood. There's gas, which we breathe, and then there's plasma. Plasma is a fourth state of matter that I cover in a different video. If you want to watch that, it should be up here. The transition between each of these states of matter, for example, solid to liquid or liquid to plasma, they all have a specific name. Generally though, they're broadly categorized when it's going from a solid or liquid state to a gaseous or plasma state. It's usually called vaporization. When it's going from a gas to a liquid, it's condensation, and a liquid to a solid, it is called freezing. There's quite a bit more about this though, and that's what we're covering in today's video. Let's get started. Vaporization, in its most specific sense, is when a liquid turns into a gas by one means or another. There's boiling, which is when you apply excessive heat and it turns into a gas. Then there's evaporation, which happens over a longer period of time. Evaporation happens just on the surface, but boiling happens from all throughout. That's basically the key difference. The other one is that evaporation happens below the boiling point of the liquid in question. Boiling happens when the interior of the liquid gets so hot that it forms a bubble of the gas of the liquid, if that makes any sense. And then that bubble will rise to the top. That's why water, when it's boiling, there are a bunch of bubbles coming out. There's water inside that has turned to water vapor. That water vapor is less dense and it wants to rise to the top and go into the air everywhere. The boiling point of a liquid depends on the pressure of the environment. It's really cold on Mars, but water would boil because the pressure is about 1% of the pressure here on Earth. There's one more transition to a gaseous phase that we think of, and that is sublimation. Sublimation is basically what you see when you see dry ice that is not melting, it's actually sublimating into the atmosphere. Dry ice is just frozen carbon dioxide. Because of the way it's made up, it doesn't want to be in its liquid phase, and so it goes directly from a solid to a gas. We call it sublimation because it's different from vaporization. Remember, vaporization is very specific. It's going from a liquid to a gas. Although I used vaporization in the title of this video, what we're really covering is all transitions between all states of matter. There are two more obvious ones, and those are freezing and melting. They're pretty self-explanatory. Freezing is when you'd have a liquid and it turns into a solid, and melting is when you have a solid that turns into a liquid. When you freeze carbon dioxide, it's not actually called freezing. It's called deposition, and that's because it's actually going from a gas to a solid, not a liquid to a solid. When you go from a gas to a liquid, it's called condensation. This might sound familiar because it is. If you have a glass of ice water, or even just ice, sitting on a table, even if you cover the top, there will still be moisture collecting on the outside of the glass. This is because the air gets so cold that it's not capable of holding enough water, and so that water has to go somewhere, and so it goes onto the coldest surface, but as a liquid. This is also what happens when it rains. Clouds of water vapor basically just turn into clouds of water droplets, and then once those get heavy enough, they start to rain. Now we're going to get to plasma, which is probably my favorite state of matter, also because it's the most abundant. Every star in the universe is made of plasma. If you want to learn more about plasma, then go check out my video on plasma. However, for this video, we are going to need some basics of plasma. Plasma is just a bunch of nuclei, which are the nucleuses of atoms, so the protons and the neutrons. Those are bound together. They're floating freely around with the electrons. Imagine it like this. If you have a mixture of peas and corn, this is similar to plasma. The peas and the corn mingle freely. However, under normal circumstances, in solids, liquids, and gases, you can imagine it like each pea would be stuck to a single piece of corn. They would be bound together and therefore not be plasma. If you take a gas and you give it enough energy, it becomes ionized. Ionization is actually the transition between gas and plasma. I almost guarantee that you've never heard this one before. The transition between plasma back to a gas is called recombination. And in a way, it makes perfect sense as opposed to all the other ones. The nuclei and the electrons, they combine back together so that you have full atoms with their electron shells. And those are all the transitions for the 4 states of matter. Now I'm going to clear up some misconceptions about vaporization. When there are explosions in the real world or in movies, things are said to be vaporized. If an explosive goes off somewhere and then there are no remnants of anything, that thing is said to be vaporized, even though it's not technically. If you don't see any remains, that's because you're not looking hard enough. If something is exploded, it's just fragmented into very small pieces. You won't be able to see them at first glance, but you might be able to find them if you look hard enough. So that is not vaporization. There's one more transition that's kind of crazy, and that is the transition from a solid directly to a plasma. I'm not entirely sure if it's ever actually happened, but it is completely possible. If a comet is coming towards Earth and it hits the Earth, and if enough energy goes into a specific atom, its electrons will fly off, and so it will just be a bare nucleus with the electrons somewhere else. The reason it did this is because there's so much light in the form of gamma rays and X-rays and a bunch of other light going onto it in one time, so that the rays are overlapping, and there's so much energy in that one spot that the nucleus and the electrons, they'll fly apart and they'll become a plasma. Once they become a plasma, they're very hot, and so they want to rise. As they rise, they're going to cool, and then they'll become a gas. After they absorb the energy, they're going to emit light of a slightly lower frequency. This is very similar to what happened with nuclear weapons. All that plasma went up into the air, it turned into a gas, but it was still emitting energy. And that energy is possibly still being emitted today. That's it for the content of today's video, but before you click away, I ask you to just subscribe. It's going to be like right here, and that will really help me out so that I know that to continue making content. Once you've subscribed, just comment about it and I'll comment back to you. If you learned something in the video, that is awesome. Share it with me. I would love to hear your stories. And lastly, if you have any video ideas, any science questions that you have, I would love to make videos about them, and I am desperately in need of video ideas from my viewers. If you comment below with video ideas, it is very possible that I will make a video that is specifically about your question and that is basically just for you. That's all I have for today, but until next time, thanks for watching.